So we've used law of sines to get one triangle and the no triangle cases. So we're going to look at here is this ambiguous case, which is basically the two triangle examples. Easiest way to visually kind of do this here is pretend we have this side here, okay, and that's going to be a set measurement. So we'll mark that up. And this angle here is going to be a set measurement, okay? This guy down here in the bottom, I just kind of stretched out, and we can fix that later. So let's say I take a line here, okay, for my third side. Now, I could put that line down to there and clearly make a triangle, okay? But you got to kind of think of this as what happens if this guy swings around. So if it fits right there, and you swing this guy down, okay, it's clearly longer than your height. Okay, we could shrink this up to make one right triangle there. If we swung it back up this way, we'd have to extend it out to make a triangle here. Okay, so if this guy swings down and it's too big, you can only have one triangle with it. Okay, now if you get this swinging leg here to be a certain length, like let's say this, you can make that triangle, and when this guy swings through, you can also make that triangle. So something similar to that. Okay, so these guys here are kind of equal. Now the difference between that is the large triangle, you're going to get this angle here, which is going to be smaller than 90. If you have a second triangle, you're going to get this guy here, which is going to be much bigger than 90. Okay, so let's look at an example with this here. So I give you B is 8, C is 10, and angle B is 45. Okay, look at what they give you. They give you so if they give us side B and angle B, automatically I'm going to use those. Make sure your calculator is in degrees. So I'm going to say 10 Okay, we know we need to inverse this. And we get 62.1 degrees. Now, if you just want to go ahead right here and finish the rest of this triangle, you can. So that means angle A here, well, I guess we should use the notation we've been consistent with. Take that away. Also take away the B you originally had, 72.9. So the only thing missing here is side A. I'm going to stay with the ratio I was given in the problem. So I did all the math there for you on the calculator. Cross multiplied, divided, side A should come out to be 10.8. So we think about if this makes sense. So angle A is the biggest. Looks like angle A is slightly bigger than side C here at 10. So that's good. Angle C is in the middle. So side C should be bigger than side B. Everything there looks good. Now, we've had this before. Okay? We came out with 62.1 right here. But the sine will also have that exact same value over here. Signs are positive here and here. So we find basically the supplement of that. So it's going to be 180 minus the 62.1. So sine has that value of 0.883 at 117.9 and also 62.1. Okay, so what we do is we kind of call this a lambda 2. So if we think there can be a second triangle, that means with this guy here, it should fit with the original given, and we should have something left over. So we have 180. If we think we can squeeze in that guy there, we're already given a 45, so that's going to make angle A now 17.1 degrees. So we can have two triangles here. Okay, so then last thing is we just got to find A again. So I'm going to stick with what was given, sine of 45 over 8. I'm going to now use this new 17.1 and find what side A is going to be with these measurements. Doing that, I find side A comes out to 3.3, so you guys may want to do these in your calculator just to make sure you can get the same numbers I'm getting, and that kind of makes sense. So if angle A goes down from the old 72 to 17, well, side A should go down from 10.8 down to 3.2. So the way you'd give me these are you'd box up each little triangle here separately. Okay, here's kind of all the work, the way the book presents this thing. So they take us through the same process here. We find the sine to be 0.883. It can happen at 61. It can happen at 117. There is enough room here so we can create two triangles out of it. Okay, they take you through everything here with triangle 1. And our answers match up, so that's good. Okay, when you give me answers, you just need to list the 3 things that are unknown. You don't need all 6 like this. For the second triangle here, they got a new lambda. That gave us a new smaller alpha, which should make side A much smaller as well. So if we go back to what we were talking about before, this side was basically set right there. We'll extend this guy out here. So what we had is we could put side in like this, or we could put the side in like this. Okay, pretty much the same measurements there. The difference is here's the short length of A, here's that long length. Okay, this is set, and these guys are set here. Here's the big one, 17. Here's the little one at 17. In the second part here, I'm going to show you guys a couple YouTube clips that give better pictures than these here, and you can also watch them for a couple examples on these as well. So see you in part 2. You have 2.